Welcome back. This is Mr. Greenstein's Geometry, and we're talking about Chapter 9.5, the sine and cosine ratios. We just talked about the tangent ratio, where we looked at two sides of the same right triangle and how they create a ratio. Now we're going to take a look at some other sides of a right triangle. So here I have a right triangle, and I have the hypotenuse and the two legs. When I look at just dealing with angle A, so here I am, I have tangent of angle A. It says that the opposite leg over the adjacent leg is the ratio that I'm going to deal with. Now I'm going to take a look at two other ratios. Specifically, I'm going to look at the sine ratio. The sine of angle A is the opposite leg over, instead of the other leg, we're going to have it over the hypotenuse. So the relationship of this leg and the hypotenuse for the sine, and for the cosine of this particular angle, I'm going to take the adjacent leg and put it over the hypotenuse, and I'll call that the cosine. So now I have the sine relationship and the cosine relationship, and these are just ratios of two sides of the same right triangle. Let's actually write down some of these. So I have a right triangle, RST, and I have all three sides marked here. I'm going to say that the sine of angle R. So the sine of angle R is going to be the opposite side over the hypotenuse. So we'll write that down. That's going to be 16 over 65. The cosine of angle R is going to be the adjacent over the hypotenuse. So we'll write that one, and that will be 63 over 65. The sine of angle S is going to be a little bit different. It's going to use the opposite side, so the 63 over the hypotenuse. So we're going to write 63 and divide that by 65. For the cosine of S, we're going to use the adjacent and the hypotenuse. So we're going to write for that 16, and that's going to be over 65. Do you notice something familiar or interesting about this? I have 16 over 65 here, and I have 16 over 65 here. So the sine of angle R is the same number as the cosine of angle S. Likewise, the cosine of angle R is the same number as the sine of angle S. So there's something special about that. Let's take a look at what that could be. The sine and cosine of complementary angles. So remember that the two angles that are the acute angles inside of a right triangle are complementary because they add up to 90 degrees. Obviously, because the third angle is 90 degrees itself. So the sine of an acute angle is equal to the cosine of its complement. Let A and B be complementary. So A and B are going to be complementary angles in this triangle. Then we know that the sine of A is equal to the cosine of 90 degrees minus A, or the complement of A. And the complement of A is, well, it's B. That's what we just found out a little while ago, that these numbers are actually the same numbers. And the same thing here. The sine of B is equal to the cosine of the complement of B, or the angle A. So the sine and cosine complements. The same thing can be said for the cosine. The cosine of A is the sine of the complement of A, or the sine of B. And the same thing with the cosine of B is equal to the sine of A. So let's write the sine of 56 in terms of cosine. If I do that, then the sine of 56 is equal to the cosine of 90 degrees minus 56, which is the same thing as the cosine of 34. So now we wrote sine in terms of cosine, and those two things are equal to each other. Let's look at the second one here. Use sine and cosine to calculate the two sides of x and y. Here we have a right triangle, and the only two pieces of information that we have inside is this angle and the hypotenuse. So if I was to write this, if I want to find out what x is the opposite of 26. So I'm going to write this by using the sine of 26 is equal to the opposite, which is x, over the hypotenuse, which is 14. If you multiply each side by 14, you get x equals 14 times the sine of 26. And if you multiply that out, you get approximately 6.1 on your calculator. Let's figure out what y is. Well, y is the adjacent to 26. So we're going to use the cosine. If I say the cosine of 26, that's going to equal the adjacent, which is y, divided by the hypotenuse, which is 14. So then I multiply this out, I get y equals 14 times the cosine of 26, and that is going to be approximately, on your calculator, 12.6. So now we have ways of calculating sides by using just the angle and one of the sides. We're going to go into part 2 and further explore sine and cosine in the next session.